Is there a figure for the arc? There's just a lot of numbers on screen. I'm trying to... Wait. Left, right, drop. Right. Yeah, but what? Okay, angle. Right.
Yo, if this is what makes or breaks your belief in the globe, then it's flimsy, man. Holy.
Right, so that's at 90 kilometers. So it's saying 2 degrees.
You wouldn't even notice that with your eye.
It shows a visualization.
2 degrees, that's like, if you ever use one of those bubble, when you bubble things that you use to see if something is flat, the bubble would still be in its parameters, register as flat.
It's showing you a visualization though, and I see a curve. I'd rather one where he put continents on as well.
Yeah. You see, listen, buddy. You see a curve, but that has nothing to do with a globe. We have curves in reality. What we don't have is a spinning water ball in a vacuum of space. That's not in reality.
That's what you believe.
No,
you say you see a curve.
You say you see a curve. He sees it at 2 degrees, bro. 2 degrees within the margin of error. It must be a globe.
It would be a good one if he had a render of the globe model of the continents on it, because then you could just go anywhere, go to where a rocket says that it was, how high it says it was, and see if it's consistent.
If you got the game Space Engine, you can you'd be able to look into that.
I have a good spec PC, so I can maybe download Space Engine. But if I set it for, well, I know you guys don't say you don't have a flat Earth model, but that's why we're kind of trapped, because it seems to comply with everything that's said about a globe. And then when we say, well, what complies with a flat Earth? You say, well, we don't have a model. And it's like, well,
you're saying that this optical curve that you observed prove everything about the globe, like gas pressure without a container, like curvature all across.
Why are you guys obsessed with this?
You saying this little optical curve that you're observing, it's also proving the motion of the ground that you're standing on, that is not in motion. You're saying it proves everything about the globe, but that's not the case. Why would you say that?
They're proved by different methods, because they're different principles.
But you just said that this optical thing that you observe is proving everything about the globe.
No. It's our globe model doesn't have contradictions. That's what I'm saying. There's no contradictions in it.
Listen, water contradicts the globe belief. That's why you have to paint blue. Well, that's why you have to use blue crayon on a globe model to misrepresent what water does.
Oliver, where's that globe model at, dude?
What are you talking about?
There's one here for a curve calculator, but this is the thing.
That's not a model. That's not a model.
when you talk about a model, the reason people don't give a formal globe model is because it's not a thing. It's a body of evidence that the Earth.
I see.
Is
So
a globe.
there's no globe Earth model then.
He said
yeah,
it's not a
there's
thing.
no
It's a not a,
formal.
it's a nothing. It's a nothing. He
Yeah.
has nothing.
There's no formal globe model as said in literature. Like, here is the globe model. That's not a thing.
Okay, great. So there's no globe model. So you don't have that. You're complaining that there's no flat Earth model?
I'm glad he admitted that there is no globe.
No. Right. It's the body. It's the entire body of evidence that forms a informal model.
All right. So the lack of actual Earth curve to be measured, that would be part of your globe Earth model?
You do measure curve. We just showed it.
Oh, where is that? That's what we've been asking for. Where's the curvature measured at?
Again, you can do it from high altitude, as we just saw.
Great.
Not at ground level.
Do that for me.
I just did. We put in the calcs.
Oh, so you calculated it. You didn't measure it.
As if bro has like a rocket that he can go up with.
A calculation is a measurement.
It's a calculation.
No, it isn't. That's the difference. You know, there's two different words there: measurement, calculation. There's a reason they're different.
They're not synonyms, bro.
Why don't you
Right, so-
make me a rocket and I'll go up there and I'll show you.
When you have flat earthers that have actually done investigations, it questioned their belief in the flat Earth.
So,
You don't. The only flat earthers that go out and do investigations usually end up becoming globe earthers.
oh, wow, that's a crazy claim. That had nothing to do with curve measurements.
Jeranism, Austin Whitsitt, like, they went to Antarctica, they were like, fuck, like, this doesn't make sense.
Those are true earthers, but Whitsitt's not like a globe.
Whitsitt is not a globe earther, you fucking moron.
He was okay. I don't know what Whitsitt's situation is.
And the only reason Jaren is because he lacked the faith for wraparound.
Yeah, Jared was kind of like pushing towards being a glober anyway before that. So
no, he was asking questions. You're allowed to ask questions. That's the nature.
He was kind of pushing towards being a glober.
Yeah, he wasn't just repeating the script. He was asking questions.
That was barely an investigation. He went there and witnessed the 24-hour sun. Wow.
Cosmos, I agree with you,
himself.
The
things that he basically said himself to not be proof for a globe. So, like, yeah, he was kind of like trying to figure out how to become a glober, right?
Cosmos, you said that this doesn't make sense.
I mean, I'm just saying, Jaren for years have been basically saying that don't look to the sky to see the measurements of the Earth, and now he's just saying I'm gonna look to the sky to be a glober. Now that's kind of like, you know.
Yeah, because it was resolved that even if you don't know what the sun is,
every video he had contradicts what he says now, and now.
That's flat earthers in a nutshell.
He deleted most of the videos because he don't want it to be used against him, because it definitely contradicts what he says now.
What contradicts what? His
own arguments against the globe.
Yeah, reality contradicts the nonsense of the globe.
No, his recent videos.
I agree with you what you said earlier. That doesn't make any sense.
Anyway.
The globe doesn't.
As in any claims about the flat Earth fall flat.
But listen, claim of the globe are by definition nonsensical.
He became a glober out of spite, bro.
No, they're not.
He became a glober out of spite. So just pipe down there.
It's the position. Well, that's appeal to motivation fallacy.
No, that's just motivation, because that's exactly what he practically said when he's like, they attacked me. So
it's regardless of how you frame it, it's appeal to motivation fallacy. That's like saying I I started claiming the sky
doesn't
is
make it
blue out of spite.
wrong, moron.
Yeah, that's what I'm saying. It doesn't make it wrong.
Appeal to motivation fallacy is pretty funny. Imagine like you're planning to kill someone, you like hid the knife somewhere. No, Your Honor, that's appeal to motivation fallacy. It's not premeditated at all.
No, because that's an action where motivation is literally part of the sentencing regime. It's not a truth-false statement in terms of like whether it's if you say I didn't hide the knife because of X motivation, it doesn't matter.
Oh my gosh, this is meta. Just shut up. Here's the thing, man.
Yeah,
you're going to go ahead and give us the actual globe measurements, and we're going to move on from there. Just give us the globe measurements. We're not talking about people today.
Yeah. Like I don't know why he brought up Jaren.
The motive isn't a hominin, by the way. It's not even, and it's against the arguer, not the person that we're talking about.
We've gone through now loads of evidence for a globe, and there's none for flat Earth. There's none. There's zero. There's zilch.
Say it again. What?
There's zero evidence of a flat Earth.
Oh, you're a moron.
I mean, every time I heard you talk about any type of measurements, you've been only measuring the flat Earth. We're still waiting for this curve. Yeah. So
yeah. The Earth's not. There's no evidence of a flat Earth. You guys don't present.
You've only been showing flat Earth measurements, literally.
With reference to what?
Reference to the horizontal plane you've been measuring this whole time.
Yeah, a plane. You can take a plane of anything. When they build on a hill, do you realize? Do you realize how it will be stupid to say?
How is a hill measured
can't
anyway?
take a level on this hill because it's not level.
How do they measure hills anyway?
Sorry.
How do they determine hills?
By looking at them.
So they measure what slope, right?
Yeah, you can measure slope.
Right, so that wouldn't be a curve measurement. Curve would be all the way around. Hill would be just a measurement from slope, from level. The difference between level.
Yeah, the slope itself can have an arc. So, yes, it can.
Yeah, so it can have an arc and will be the difference between level, right? So you would still need a plane reference.
Yeah, right.
On the Earth.
So you create, you assume a plane.
Not done, Donald. So that would still be a reference to a flat plane in order for you to do anything with hills.
Yeah, a plane in reference to the vector of gravity. Like perpendicular to the vector of gravity.
You haven't proven that yet. We're only talking about these measurements. And you already just explained to me that even when you're measuring slopes or things like hills or valleys or anything of that, you require a plane to measure the difference from, which means that it would still be going horizontally.
Yeah, horizontal doesn't even make sense.
Horizontal is a plane that you're measuring the difference from with hills, sir.
Yeah, I'm saying it doesn't even make sense because you can't even reference what down is.
Yes, it's required if you represent a slope. You require that. If you're measuring any slope, you need a plane in order to have that difference from. You're measuring the elevation.
Yeah, but the plane becomes purely abstract, right? In any case.
Doesn't matter. You're still using it. It as a reference
and it's an abstract plane. So I'm glad we agree. It's an abstract plane.
It's an abstract plane that is required to begin with.
To make it a level building.
Wouldn't be required at all.
To make a level building, sure.
Listen,
what I'm showing.
If the Earth was a globe, it wouldn't be required at all. It wouldn't even be a hill.
If the Earth was a what?
If the Earth was a globe that curved, all going all the way around, where you guys could walk sideways and upside down on the other side, wouldn't need a plane. You would be measuring Earth curvature.
Yeah, you take an abstract. You take an abstract plane. There's literally no contradiction with curvature because you're just taking an abstract plane.
Abstract as in what? Would you define abstract plane?
There's no real plane. It's just an abstraction. You're just taking it for the purpose of a tool for measurement.
Abstract that is required for you to take the measurement in the first place.
Yeah, the same works with numbers. Numbers are abstract. It's things we attach onto numbers that give them like real, like 2 apples or something. Doesn't mean the number 2 actually exists. It's just a description.
Yeah, whereas numbers are just abstract, them by themselves in the representation, but we're not talking about something that is abstract. We're talking about measurements. That's something that you're actually measuring.
You're right. So
he realizes the ball is abstract.
Emotional damage.
Yeah, you seem to be confusing abstracts and numbers.
Why are you gay?
And calculations. There's a difference between numbers, calculations, and things of that nature. Hold on. There's a difference between numbers, calculations, abstracts, things that stuff that you're talking about right now, then physical measurements. You have a physical measurement of the globe. Sir.
Yeah.
Great.
Joe, can I say something?
A physical measurement of the globe, sir.
Joe, can I say something?
Just arguing about descriptions is not going to help you. Because only this thing that you're describing right now, even with those abstracts, is a horizontal plane that is being referenced to get your hills and slopes.
Yeah, an abstract plane.
Oh, yeah.
Yeah, horizontal plane.
Yeah, horizontal plane.
It's just a tool for measurement.
But it's kind of funny, but that's what you are measuring.
Yeah. You're using it as a tool.
Yeah. So it's a measurement. So you're measuring something physical.
Okay. Right. If I measured the diameter of an apple, right, I'm not saying that like 10 centimeters exists. I'm just describing the apple in those terms, in numerical terms.
Yeah, the apple exists. You're saying the apple exists,
right?
Just like the plane does.
And how you're measuring the apple.
An abstract plane. You're using it for measurement.
Yes, you're using it. Okay, you're using the plane. If you're measuring the Earth, how are you measuring the Earth? Let's just go there because you're trying to run away from it.
So it's what complies with all observations and measurements is a 12,500 kilometer diameter Earth.
What measurements?
Right. Because we already established that measurements are physical.
Yeah, the measuring instruments.
Okay, great. Right. And we already talking about the measure. Okay, the instruments is also physical. And anything that you're talking about, as far as numbers and concepts that is used, right? In order for you to have the descriptor points for these measurements, you need the thing that is physical in order for those things to be describing. Like ground positions.
Yeah.
Or geographical positions. Just the word by itself. I don't know why I have to explain this to you because it seems like you're trying to be funny. Just the by itself, geographical positions on this plane or being a representation. Yes, the word by itself is just a concept. That's just an abstract. But what the word is actually representing is a physical place that's being measured. That is not just an abstract, sir.
You'd have a physical place, but a physical place is not a physical place is not a plane.
Yes,
it's an actual place.
It's not a physical place. Yes.
Yeah, so plane is not a physical place. That's fine.
Yeah, so when you when you enter in the position where the observer is standing in the ground position, is being parallel, right? And those measurements is basically being taken using the abstracts, which is linear. All of those are flat Earth representations of measurements. Yeah. So you are measuring a flat Earth at that point, sir.
If I may just interject for 2 seconds, literally, a plane is physical. The plains of Africa, that's a physical location. It's plain. I can walk across it. Don't be silly now. How can you say it's not physical? That's outrageous.
He's trying to say that is an abstract. There's a representation of the two. Right.
This seems like it's very difficult to explain a simple concept. The continent of Africa is physical, the plane
You know
of
what's not
reference
physical? You know what is not physical? A globe that you can walk on top or on the side or on the bottom of it.
The
That's
plane
not
of
physical.
reference is the plane of reference. Reference being a representation is the ground that the observer is standing on, and the ground that the observer is standing on is on that plane of reference, and the measurement from that ground, right, is being measured from the observer standing in the geographical position, which is using the horizontal straight line because they represent the horizon.
Exactly. It's a physical endeavor. That's what it is. A physical
no matter
endeavor.
how, hold on, even if I give you that abstract argument that you're making right now, even in that argument, what is physically being measured is horizontally or a flat earth, a plane from the ground where the observer is standing in the geographical position, using the stars, using celestial navigations, which is a right angle triangle. So even if you want to say all of that is abstract, it is basically being that. Hold on. Even if you want to say all of that is just concepts, those concepts is in representations and referencing physical points, which is the geographical position in the ground where the observer is standing on. Now, you can say that you guys actually say y'all have something that is called dip correction, where you're making the claim that we actually take these measurements at the center of the earth. But you will have to basically, show us how do you dig to the center of the earth to take physical measurements there.
Yeah, nobody's dug to the center of the earth.
Yeah, I know you haven't. I know.
Why are you asking these impossible things? And also, why are you so close to the microphone?
What?
Like your lips smack when you talk.
Okay, and remember that the Kola super borehole is only 7.6 miles deep. That's 12 kilometers. And when what they predicted to encounter during the 20-year ordeal, they were wrong every step of the way. So there's no way they can tell me what is 4,000 supposedly deep in. We don't even have the technology to see that deep of the Earth's surface. We don't have that. So they were wrong for 7.6 miles. So they can't tell me what's 4,000 miles.
We don't know for certain what's down there. And you realise it was
the radius is the point, isn't it? So what other measurements do you have? You said you had them. What are they? You said they were everywhere, obvious, and all that shit. What measurements? Not this one.
It's definitely not this one.
Again, references of light from celestial objects. And by the way,
no. We're trying to talk about the surface of the Earth, and you keep going to celestial objects. We're talking about level, which has got nothing to do with celestial objects unless you want to measure the elevation above a level surface. That's a problem. But we're talking about the surface of the Earth. You said it was measured. That's why we're talking about the radius of the Earth and digging through the physical Earth, not looking at stars. So let's stay on the surface of the Earth. You said you got measurements of the surface of the Earth. So can we have those, please? That's all we need, isn't it?
You know it's a red herring, so that's why you keep
surface of
appealing
the Earth,
to it.
and that's the thing in question. How's that a red herring?
It's a direct response.
How do you measure the Earth from ground level? What does that mean?
Survey the land. How the fuck do you think we build upon it? How do you think we have vast engineering civil structures upon the Earth? Bridges, tunnels, these things. Do you think at any point we're going to be measuring the Earth?
Yeah. What do they assume? What do they
that's
assume?
how we do it. What a silly question. So can we measure the surface of the Earth? Yes or no?
No, we measure parts of the surface. That's all.
So we measure the surface of the Earth. Everywhere we go, we measure the surface, don't we? We measure it.
No. Right.
When we measure the surface of the Earth, do we measure curvature or do we measure it to be a horizontal plane?
We measure curvature over long distance.
Can we have the measurements of curvature, please?
Yeah, just provide that.
Well, if you look at long span bridges,
no, go and get it. And if a long span bridge, that's going to have a measurement of curvature in it that they're going to have to account for. So they
long span bridges.
Go and get it to account for.
Yeah,
not the bridge curving, the curving they had to account for when they surveyed the land. Show me that.
Yeah, and just before you do go off, the longest bridge in the world, which is in China, the King Dong something or other, 102 miles long, Earth's curvature was not considered during its construction, okay? That's 102 miles. Okay,
That's
go and have a look for it.
Uh-oh.
So the measurements, please.
Great to hear your voice, by the way.
I was going to say, Jen, I almost called you Jedi then, and that's fucking me. It's good to see you, Jen. Glad you found your way here. I'll send you another link to another server, man. You might also be able to get in there as well.
All right, cheers, man. I'm looking forward to it.
Cool.
Wicked.
So measurements of the physical curvature of the Earth, please.
Good to hear you guys.
And yourself, man.
I just want to say, Joe, like when you talk a bit further from the microphone, because it looks like you're eating the microphone.
My mic is just.
Is it called the Danyang Kunshan Grand Bridge?
Measurements of Earth curvature is what you should be getting.
Did the dog eat your Earth curve measurements or what?
I don't even get what that means.
The Chinese bridge is correct. The Kamnan Gongyong,
turn it down,
Ling Lang Long, 102 mile long bridge. No Earth's curvature was taken into consideration throughout its construction of 102 miles.
Yeah, what's your source?
Where's this Earth curvature
source is
measurement?
there. You're meant to be getting the measurement.
Jen.
Right? Yeah.
Got to help me, dude. All right.
Yeah,
I know that you dropped a great big bomb on him and he's going to follow that trail, dude, but he said there's measurements of curvature of the Earth. It's always there. We always do it, blah, blah, blah. I'm asking him to go and get it. He needs to concentrate on that.
I'm not going to find it because I disputed what that even means.
What measuring, surveying the land?
Yeah, because land can vary.
You don't know what surveying is?
Surveyors take a measurement of like a certain portion of the land. What does that mean?
Yes.
I could be on a mountain.
You said that they measure curvature there. He's just asking you to get it.
If I'm in the Himalayas, what am I going to measure?
I don't care what you're doing.
No, you're going to measure the elevation off of sea level. That's what you're going to do, bud. You're going to find out how high you are off of a horizon.
Yep.
No.
Yeah.
Who told you this?
It's quite simple. It's a right angle fucking triangle. When you're at distance, you can measure the angle of an object from the surface, its elevation. When you measure that angle, and for example, you know the distance to the mountain, you can do some very basic math we all learn at school, figure out the height of the mountain. Transversely, if we know the height of the mountain and we measure its elevation angle from mean sea level, we can figure out our distance to it. It's quite handy when we're navigating. So these two processes, surveying the land and then navigating the land that we've just fucking surveyed, is going to take place on a horizontal plane. Now, where's the curvature? Why? Because that's the measurement we used. Distance from point A to point B along the horizontal adjacent of the right angled triangle.
And why couldn't it be done on a globe?
Because you cannot measure angles from curved lines.
Because you haven't proven that it is a sphere yet.
Sorry, what's the definition of an elevation angle?
I got no idea.
Okay, it's an elevation taken from a horizontal. So, for example, that star over there is 15 degrees above the horizon. That's going to be an angle measurement. Now, within the definition of an angle, the intersection of two straight lines that meet at a vertex and the measurement in separation of those two straight sides, you can't have a curved line because you won't be able to measure the separation. No longer fits the definition of an angle. You won't be measuring elevation angles up from a curved surface Earth. You won't be having right angle triangles on the surface of a curved Earth.
That same star isn't going to be 15 degrees everywhere on Earth.
No, it's going to fucking move, and you're still going to measure its elevation angle. 45 degrees now. Fuck now, I'm underneath it, that's 90 degrees. Still an angle measurement.
So you're saying like the star is very small?
No, I'm saying the surface of the Earth we measure as a horizontal plane to utilise this very specific thing called triangle.
No, but for the star to be like
not talking about the star, we're talking about the surface of the Earth. Please don't be like the last gentleman. We're asking for surface measurements of the Earth, not about the stars.
Yeah, notice we.
Why does it matter?
Because that's
what the surface. Have you read the question? Have you read the name of the room? Flat Earth. Earth.
Okay.
Surface description. Flat. Topic of the room is the surface of the Earth, not the stars.
Well, okay. This is like if you. Can I say something? This is like if you held a magnifying glass.
What does it matter if you want to say something if you don't hear what people are talking about it? It doesn't matter what you want to say. So just mute yourself.
So
Cosmos needs to get the measurements of the surface of the Earth.
You're saying we don't look at the stars, and then you're saying we use a triangle in reference to the stars.
Yes. But that's going to be a measurement of the surface of the Earth.
Right, in reference to the stars.
So when we talk about stars, we can measure them from a horizontal plane. It's quite useful for navigating.
So we are using celestial objects.
Gentlemen disagreed that we use right-angled triangles with mountain. I was pointing that out.
So
do you mind if I jump in here? I see where you're coming from in terms of like using the elevation angle as measurements on a horizontal plane, and you're saying that's not possible on a curved surface. However, I guess in my head, in my imagination, if this curved surface is so incredibly massive, I think it's pretty easy for you to use your imagination and continue that flat triangle straight going across the curved surface, right?
Cosmos, shush. Thank you. I get you. All right, the Earth is so big, and the measurements are really small, and if we put it's not really going to make much difference. It's amazing the distances that we can measure with this right-angled triangle. We can measure, for example, the distance to the equator, because that would be the minimum elevation. But we don't usually see the stars on the horizon. It's usually about 15 degrees upwards from the horizon. And then so on. But we can make those measurements. If the star is 15 degrees above the horizon, I subtract that 15 from 90 and have 75, and then I add that, I'll multiply that 75 by 60. The distance is 5,400 nautical miles. That's a long distance. That's almost a distance from the North Pole to the equator. In actual fact, it's 15 degrees north of the equator. So that's a straight line measurement, dude. Over 5,000 miles in this.
A straight line measurement to the center of the Earth.
No, straight line measurement along the surface of the Earth, because we're navigating now.
And it's all using a plane to be a horizontal reference. That's the point. So each geographical position is on that physical plane, which is a horizontal reference, the same ground where the observer is standing. Now, you guys claim that the surface is actually curving. Which is a horizontal reference, the same ground where the observer is standing. Now, you guys claim that the surface is actually curving. You guys is going to have to explain that, because that will be contradicting the physical measurements that Jedi just explained to you.
Why has it gone so silent? You're waiting for me to respond?
I have a question.
I just want to say, Jin, is Jedi one of your Jedi, I guess?
So there's questions instead of getting the curvature measurements that you guys claim you got from surveying?
I'm not claiming this. I want to ask a question.
Go ahead.
Why can you not see the star Polaris from Australia if the Earth is flat? The star Polaris is the North Star.
Yes. Why can't you see it when it's descended beyond the horizon? That's
No. Why can you not? Why is it not visible from Australia?
I've just told you, because you're too far south. The equator, that was at 0 degrees, right? Now you're south of the equator. This perspective or view of the sky is known as the celestial sphere. It doesn't mean that the things are actually getting closer to the fore, by the way. That's just a form of perspective. But the reason why you can't see Polaris anymore is it's too far away for you to observe. Your eye, can't see everything in the world around you, dude. You have a hemispheric dome of vision above you and around you, as we all do, where the stars go from one horizon over your head to the other horizon. Those stars fill that hemisphere of vision. You measure those like you're in the center of a protractor, measuring the straight line angle measurements from the horizontal line, like within a protractor representing the surface of the Earth. But the reason why you can't see Polaris is quite simply because you're too far away.
So how far away is Polaris?
I don't know how far away Polaris is. I know where its geographical position is.
Well, how do you know it's more far away if you're from Australia than if you're in Europe? If you don't know how far away it is.
What do you mean I've gone from being underneath the star, saying at the North Pole, and walked away from it? As I walk away, it descends downwards towards the horizon. As I walk further, I obviously can't see it anymore. It's beyond the horizon, the limit of my personal view.
But the stars are above the Earth anyways. So
yeah, like a ceiling, which appears to descend downwards towards the floor as you look horizontally down the corridor. It's not actually getting closer to the floor. The floor is not actually ramping up to meet the ceiling. But that's just perspective. Same thing when you look up at the sky at night. It looks like a dome of vision around you. But like I said at the beginning, the stars aren't actually closer to the floor on the horizon.
I don't think we actually had a physical location of the stars in the sky.
Sad that we have to explain to the grown-ups.
But again, we're talking about things in the sky and celestial objects instead of the surface of the Earth. Do you guys know what room you're in?
Am I supposed to look at an anthill from with a magnifying glass and say this is the Earth? This is the entire Earth. Why can I not have a expanded perspective?
No.
What did you do to these guys, Jedi? They sound like they're so. You tell them one thing, and they look at a star. He's like, "We're on the ground measuring an angle." What do you mean a star is flat and far away? That's not what we said. We said the ground is flat and we measure an angle. What do you mean the moon is round? It's just fucking ridiculous with these idiots.
It's been a fun couple of hours.
Jid, if you're not taking
What do
over
you
this
mean
server
level
now,
isn't curved?
Did Cosmo come up with those curve measurements yet? We still waiting. I think it's been like an hour since.
what do you want? What are you waiting for, bro? I'll hook you up.
Wait, so what is hiding in the North Star?
Oh, so no measurements of the ground.
Now we've got people hiding in a fucking star. This, I don't know what you did to them, but I'm pretty sure they're mentally retarded at this point.
Nah, man, these poor people are
Are you able to like visualize Earth and the North Star together? Like, how am I not able to see it when I'm on one place of the Earth from another?
Shock horror. It's like, you've moved so far away that you can't see it. It's like I explained this earlier. Like, maybe I should dumb it down a bit. It's within your example. Why is it when I go over here far enough away, I can't see that thing anymore because I've travelled far enough away from it? Why is that? Scratch your head. You're too far away.
But doesn't that imply that
so
the
you're
stars
saying
are
like,
really close?
I mean, there could be more than one reason, but hey.
You're saying that if I had the telescope,
yeah, go on.
If I had a telescope, then I would be able to see it.
No. I told you that on the horizon we don't usually see stars anyway, because that's the thickest part of the atmosphere. It's going to be a problem with an optic looking horizontally through it, because at a distance of about 200 miles, the atmosphere that's opaque and gets more and more dense with distance acts like a wall that light can't pass through. The sun, that's fucking bright. There's a huge ray of light that can burn through that atmosphere, but a star, good luck. That's why it's easier to look up, right?
Yeah, but doesn't Polaris like align with the poles?
That's where we get it from. Polaris, the North Star, is a circumpolar star. It rotates around a point in the sky, a centre of rotation. Directly underneath that, expressed as 90 degrees north, where the vertical line from the star meets the horizontal plane perpendicularly, that's the geographical position on the surface of the Earth.
So
measured from a horizontal plane.
So Polaris would have to be very close in order for you
not
to
making
lose.
a claim to the distance of the star. We're just expressing the geographical position. You asked where North was.
Yeah, I think it's fair to say, though, that as a flat earther myself, I don't accept the number of 430 430 light years away. 1 light year being 6 trillion miles. So that'd be 6 trillion miles times 430, and that's the distance to the North Star. Now, I'm not accepting that as a distance. Okay, so it's not that distance. I can say that.
So from what I understand, the reason why you won't accept stars is literally you don't see them as like distant suns. You're thinking that they're much more closer, and because they're much more closer, visibility will change depending on where you are on the planet.
Well, not exactly. We don't know the distance to those stars. They're there. We don't know the distance to them. So whatever number's given to us, we don't accept it. And the thing about the North Star is that, as Jedi's been trying to tell you, as you move across the flat Earth, moving towards, let's say, Australia, and you're walking backwards, you will see that Polaris starts to drop because you're moving away from it. It starts to drop down to the horizon. It will drop to a point where you won't see it anymore. You're out of range. I'll give you another example. You're walking down on the pavement in England. There's a manhole cover. You can't see it yet. But then suddenly you see this black oval thing, it's an oval. It's actually a 360-degree circle, but it looks like an oval. As you move towards it, it starts to become circular. You get 90 degrees right above it, it's a circle. You see what I mean? That optical illusion. A flat surface can obscure your visibility, and you're standing up in this case, but you didn't see that manhole cover because you were out of range of it. See what I mean? Do you get
No, the manhole cover is on the ground, though.
Yes, it's on the ground. Okay, but the thing is, you couldn't see it until you got close to it. That's
yes,
my
but
point.
if it was in the sky, I would be able to see it, though.
You see it, yeah, but then as you move away from it, it will drop. Same principle.
No, it
It's going
wouldn't.
to drop. It would.
Wouldn't.
It would.
On a flat Earth, no.
And it does.
It would not.
Not only it wouldn't. Not only
Sorry.
wouldn't it. It does.
Sorry, Jim.
Because you can't
Sorry,
see
Jim.
Polaris in Australia.
Sorry, Jim. Very quickly. Does perspective exist?
Who?
To you, who said no, it wouldn't. No, it wouldn't. Does perspective exist?
Sure.
Cool. So, for example, the light in your room, when you stand underneath it, it's directly above your head.
Okay.
But the light on the other side of your room that's attached to the ceiling, that's not directly above your head, is it?
Sure.
You'll notice that the ceiling appears to get closer to the floor when you look down your room. Like when you look down a road at night.
No, it doesn't.
It doesn't. When you look down the road at night, does the road not ramp up to the midpoint of your view and the street lights appear to descend downwards towards the horizon?
Well, it depends on if
yes
it's a straight road or not.
Yes, it's actually a straight road. Is this perspective?
And what does this prove?
Recede, let's say you've got two objects, the top of a light, like the street light, and a car on the road. Do they appear to get closer the further the car gets down the road? Do the lights appear to get closer to the car?
Well, they are physically getting closer to the car.
No, not physically. They appear to. They actually haven't changed their height above the road surface. Let's say they're 14 feet above the road surface, continually down the road. It looks that way, though, doesn't it?
So you're saying that, as it's further away, it seems like it's closer to the ground, and when I come closer to it, it seems like it's above me. Is that what you're saying?
Yeah, things appear with distance to arc downwards towards the horizon.
So that would mean the Polaris star is like in the atmosphere. It's so like close to the Earth.
No, it's just above your eye line, and as you walk away from being underneath it, because you're no longer underneath it, it appears to get closer to the horizon the further the distance you walk.
Yeah,
it's perspective.
Does anybody have anybody can draw this with crayons and then take a picture and show them how this works? Because this isn't working.
I would love to.
Hang on, this is like a double-edged sword because from the North Star you can see from our globe from the northern hemisphere. So when you're talking about like changing your location, like vast distance, I can go from France to like North America and I can still see Polaris. But if I go to Australia, then I can't see Polaris.
Yeah, that's because
that's speaking from the real east level. You cannot observe stars from a globe. You can't do that.
Sorry, James.
Apologise. Sorry. Can someone send me a map of a flat Earth so I can sort of visualise?
You cannot observe stars.
Is there a reason why you guys is not like avoiding showing any globe proof, or what's going on?
Well, it's like
we had to explain perspective to you, like you guys don't know what that means, or you guys
we know what perspective is,
and that's
when we ask clarifying questions,
the other guy didn't.
Go, oh, we're not proposing a model. We're not proposing a model.
Speak for yourself. Don't speak for your friend. He didn't know. You had to have it explained to him.
He's not my friend.
Okay. But that is like indirect, like reasoning anyway. Is like when someone comes with evidence, basically making a claim about the Earth's surface and saying that, well, here it is, what's backing up my claim, which is deductive reasoning. You should be dealing with that. You shouldn't go to the inductive part. Like the stars that are physically in the sky, you don't know the physical location of the stars. That's why they in an apparent location to begin with, because of perspective. So I don't know why would you try to use that as an argument when you guys is talking about the surface of the Earth. That's why Jedi said, like, okay, hold on. That's why Jedi said, and you guys seem to miss that part, that he's not referencing the stars or any celestial body, right? Like the sun or the star Polaris. He's not referencing the stars for the physical distance in the sky. He's referencing the stars through the geographical position, which is the ground position on the Earth's surface and how it's being measured.
Yeah, but to be
That's
fair,
what you should be dealing with.
Yeah, but
so is he. He's using. Yeah, I get what you're saying. He's using the star as a tool to help explain the shape of the Earth. So is this guy.
Using it as a geographic. Yes, but he's using the star as a point, as a geographical position, which means that where the star seems to be aligned using the celestial navigation or using celestial angles or elevation angles, where the stars being aligned. The geographical position is at the zenith of the star. He's not using it as, well, here's where I could see the star, or this is the physical location of the star. And he's not using the position of the star in that point. He's using the star to reference the ground. And that's what you guys should be dealing with.
Okay, let me reply now, because I tried jumping a few times to get going in circles. I don't know, man. But I'm pretty sure he was. That's what he was doing.
Listening.
Sorry, I'll let you speak. Why are you talking over me, bro? What's this?
Because you was talking over me the whole time. I'm trying to get you to understand what I'm saying. Okay, listen. I want you to understand what I'm saying. He's not using the star as, I'm on the ground and this is where I see the star. He's not using it as a reference. He's not using the star as, this is the physical distance to the star. He's using the star as, using it as a measurement, right, from the ground where the observer is standing in the geographical position. Now, it seems like you don't know what a geographical position is. A geographical position is a ground position that is at the zenith of the star that you are referencing and your line of sight using elevation angles. That's what he's saying when he's saying, I'm using the Polaris. So that's what you guys should be attacking, because that is an actual flat Earth proof, because you need a horizontal baseline in order to do that.
I'm trying to respond to you, bro. You just keep rambling. So thank you so much for repeating everything all over again, just because you felt the need to interrupt me. I don't know what that was all about. But anyway, as I was trying to say,
go ahead and repeat that all back to him so we know that you heard him.
Yeah, go ahead. Repeat it all again from the top.
That's not me talking. That's your buddy talking. I'm about to let.
I know who that guy is.
Yeah,
he's on your side, bro. Anyway, like I was trying to say, I understand what you're saying.
I want you motherfucking Globers to repeat what he said, so we understand that you know what he said. How's that?
Okay, I will. I'm trying to. You just won't let me speak. You keep interrupting me, bro. You keep talking over me. I'm trying to. All right, can I talk now? Okay, here we go. So I understand what you're saying. You're saying that he's using the stars as tools to help explain the shape of the Earth, right? Fine. So is this guy.
Okay. This is why you guys got to listen. That's why y'all talking.
No one ever said that. No one said that. Where did you get that from?
He's using the relative position of the stars to help explain the shape of the Earth. That's what he said.
No.
Not explain.
Not explain. Measure and describe.
Okay, fine. Yeah, sure. Measure and describe. I'll go with that. So am I wrong? He's using the stars as a tool to help measure and describe the shape of the Earth. Or explain.
Negative. That's incorrect.
Negative. The surface of the Earth, not the shape.
Are we not getting into semantics then? You asked me to fuck it in for
Yeah, but you said a shape is completely different from the surface of the Earth. We don't know the shape. No flat earther in here knows the shape of the Earth. We know what shape it isn't.
Can I just point out, that all I was trying to say there is your argument was he is not allowed to use the Star of Polaris in this argument, and I'm saying you're doing the same thing. You're using the stars as a tool to help describe and explain the surface of the Earth, however you want to word it. So is he
using Polaris?
That's why I cut you off, because that's not what I'm saying. That's not what Jedi is saying. It's just saying what you guys rebuttal to his argument is a non-secular,
I joined like 5 minutes ago, bro.
Okay.
I don't even know this guy.
Okay, you do understand that you are in a room that's called Flat Earth.
Oh, really?
Yeah, so anything that you're talking about with the sky is irrelevant to anything that he's talking about, because he's only using the star. This is why you're not understanding it. And he said it like 10 times, and you guys keep going around in circles, and then you're going to accuse us of going around in circles and keep repeating ourselves, because you guys are just not getting it.
All that I wanted to jump in and say was so is everything that Jedi was talking about elevation
angles, yes. Elevation.
Fucking hell. Yeah. Elevational degrees. There we go. I got it out. Gosh.
Okay.
So the reason why I brought up Polaris is because, the reason why you cannot see it from Australia is because the Earth is in the way.
Oh, it's because of perspective, bro.
Yeah. You know why you say you can't see Polaris? I want our guy to finish his point, though. What was he trying to say?
Well, as that fucking guy said, using stars is irrelevant in this argument because we're talking about the flat Earth. So all that I was trying to say is that applies to you guys as well, right? So the whole thing about stars and fucking degrees and all that shit is irrelevant, surely.
Right. Shall I help? I know you only joined the conversation 5, 6, 7 minutes ago. We were asked where North was. And that's how we got down to looking at the stars. Because the surface of the Earth is directly underneath that point in the sky that the stars in the north rotate around. So that's how we got to where North is, because we used the stars to describe where North is. Same with South, right?
Yeah.
That's why.
So if I was in Australia, I could not use Polaris as an indication of where North is.
No, you wouldn't be able to see it. You'd have to use other navigational stars and tools to do that.
Yes, it's too far.
You'd still be using
the same that lack of visibility comes down to like angle, perspective. It's just too far away.
Yeah, so if you would understand that when you stand out beneath the night sky, the sky that fills the field of vision above the surface looks like you're standing inside a dome. The stars towards the horizon look close to the horizon going downwards. The ones above your head look higher in the sky. They're not actually in these positions. They just look like they are to you making the observation. Like when you look down the road, as I was pointing out, when you look at lights and cars below or above your eye line, converging with your eye line at distance.
Yeah, I'm totally with you. So it's like perspective, right? So like this is one thing I wanted to ask you earlier is the whole horizontal elevation degree measurements. I've seen this before, this kind of image, but I'm pretty sure those triangles, when they're drawn out, are bent and curved with the shape of the Earth. I'm pretty sure the measurement calculates.
No.
You don't have an angle then.
No. So what we do is, if we're going to be navigating, we can start by just charting our position, like using straight edges, circles that draw, compasses that draw circles, and angular bearings. Right. This is all going to be straight lines, dude. Everything that we do with navigation, right, on the surface of the Earth, even our bearing azimuthal directions. I'll explain what that is so you understand. If you can imagine, you've got a circle around you, right, and let's say you're facing north. 90 degrees to the left, that's east. 180 degrees behind you, that's south. And 270 degrees as you keep going around in a circle, that's west. These are azimuths. Now, these are directions. Now, those are horizontal bearing angles across the surface of the Earth. So when we're navigating, apart from using time and stuff, because the stars move and shit, what we do is we measure the elevation of angles above the surface to figure out that geographical position, so we can draw bearing angles, horizontal lines through them, and when we make enough measurements, we're going to have the intersection of lines or circles, depending on what we do, to figure out our location. It's all flat Earth, dude.
But why don't you know?
How did you come to the conclusion that it's flat? Because surely on a local level it seems flat, but on a large scale it's curvature.
The distances we can measure beyond 5,000 miles just by using the stars in the sky, utilising it.
The stars, as we discussed previously, are relative to your location.
If you had two observers at different latitudes, then would they both get the same angle for the same star?
No. Two observers on different latitudes will not get the same elevation angle to Polaris where we get latitudes from, because the circles are dependent on the elevation angle to Polaris.
But surely if all the if all the lines were straight, then surely they'd all be consistent.
Dude, it's circles around a geographical position. I'll give you an example. If I'm standing directly underneath the North Star, this is going to be 90 degrees north. I move backwards, still facing Polaris, and it descends by 10 degrees from the vertical. That's going to be 80 degrees north. Keep moving backwards by 10 degrees, and they're going to be circles of equal altitude around that geographical position. Each latitude line is going to be measured by the descending angle of Polaris towards the horizon. When I get to its minimum elevation, this is going to be a circle around the geographical position at 0 degrees. We call this the equator. These are all measured utilising a right angle triangle and then drawing circles around that one geographical point.
So would you would agree that it should be like 100% predictable then? If you know exactly where north is, where that starting point is, you should be able to predict where the sun will be, or sorry, the North Star will be on every position, right?
Yeah, it's
if it's
the North
100%
Star.
straight, you should be able to fully
The
predict
North
it.
Star is also a circumpolar star. It moves, but it moves around a stationary point. That
But I believe
stationary
that's
point
why
is
they use
above.
time, right?
Why are you talking for me, dude? I'm trying to help you.
I'm sorry, I thought we were having a conversation, mate. Bloody hell.
It's just it's fine, but ask your question, dude. I can't hear you when I'm talking, right? So ask your question. Ask your question, dude.
What do you mean, bro? You were just crying that I started talking. I'll mute.
Yeah,
I'll let
I've
you finish.
stopped now. I just want you to ask a question. Fuck.
Well, you were talking about the fucking star moves or whatever, and I just said, oh yeah, that's why they use times, right? They use times along with elevation angles.
Use what? Sorry, time. Yeah, they're going to be using time for sure. Chronometers back in the old days, we've got more accurate with time as it goes. Those things move predictability about them, right? Throughout the year, throughout the seasons, these stars are going to move across the night sky. Depending on where they are at a certain time of year, we can use them to figure out our geographical position. Yeah. We get longitude and latitude from observations of things in the sky. We wouldn't have longitude and latitude if we couldn't observe the things in the sky. Sun and Polaris in this instance. Also the southern circumpolar stars as well.
So do you agree with the other guy that was saying using stars is irrelevant?
It's not irrelevant. What it is utilising a prerequisite of a horizontal plane.
Yeah.
It's not irrelevant if we're talking about, well, at this position and that position, what's north? Right? When I make this observation from here, why can't I see it anymore? We're always talking about the things in the sky and why we can't see it. We have to understand that you're making the observation, it's perspective. Utilising how we see the world, it's like a protractor above your head, and you can measure angles from your centre point at the bottom of a protractor. So it's a handy tool, but it's utilising the prerequisite that the surface of the Earth is horizontal.
Yeah, man, for shizzle, man, there's all. Sorry, I don't want to speak over you. I don't want you to lash out at me again. I'm scared now. I mean,
Mute the retard.
I just wanted to say hello to Jin anyway.
Yeah, how you doing, Oleg? You're doing all right, yeah? You're learning about the flat Earth now.
I'm
Yeah?
very well. Yeah, I was enjoying the conversation. It does seem pretty hostile in here. I wasn't even trying to talk shit. I was generally just coming with some questions, but yeah. But it seems like you've definitely built up a bit of an army in here, Jin. Fucking hell.
This is the place where you learn the truth. This is the flat Earth 24/7 university. What you're learning here, they don't teach you in university at all. Okay.
Yeah, it's just quite intense.
Yeah, has to be. Because we're trying to break the indoctrination, or let's not use that word, but the information you got, which is misinformation, which you're hanging on to because that's what you've learned. We're now trying to undo that and help you to see that what you have learned is misinformation. It's not correct. And the reason why you're carrying it is only because you haven't tried to validate what they've taught you. Now you're trying to do that.
I think it's a very valiant mission. I mean, I'd love to see how I can help, maybe marketing, something like that. We get some posters designed, made up. Do you know what I mean? Get on a
That would be good.
recruitment hype.
You could do that. Yes, that's going to go a long way.
I'm going to pull over so I can mute him.
You can get some brownie points with that, so that's going to be good.
Yeah, come on. Well, let me know what to like put on there or whatever.
Yeah. But anyway, so you understand now that, of course, we use the North Star for navigation. Okay. We're not saying it proves shape because we don't know shape, but we know that it's not. It's not because you can't see it, not because of the curvature of the Earth. It's the flatness of the surface that's doing that. Okay, a flat surface can obscure your ability to see an object. Okay. Aha.
No, I see where you're coming from, and I guess the maths doesn't lie. I liked your analogy with the whole brain on the street. I get you.
Yeah.
Because you are right. I mean, if you just mirror it, it doesn't make a difference. I see what that guy's saying. You would have thought if it's above you, you'd still be able to see it. But I guess if you actually just mirror it, it doesn't make a difference. I mean,
right.
I guess
There's another one as well, Oleg.
Massive distance could help. You'd have to be a lot further away to. I don't know. Sorry, go on.
Yeah, I was going to say the basketball court where you put your mobile phone face downwards underneath the basketball net, and then you walk back from it to the other basketball net, lie down, you won't see your phone until you get onto your knees, and then what you will see is the slither of your phone, the edge of it, because you won't see the whole thing. You stand up, and as you walk towards it, that optical illusion is happening where the phone begins to morph its shape into what you recognize it when you're 90 degrees above it. And as you walk back away from it again, it starts to change shape again. There's an optical illusion, real time happening. We are surrounded by it. It's just that we take them for granted.
I'm curious because you're saying it's an optical illusion. So are you saying that the stars are far away and there's just some sort of an illusion that warps their image, or are they more closer and they're still the image is still being changed?
Stop talking about how far the stars are away.
Yeah. You took the words out of my mouth there. We don't really talk about the stars because we don't really know what they are. No human being does. There's a lot of lies going on.
Hang on, you guys were talking about angles, about how sailors navigated. Can't you do the same? Can't you use parallax to work out where the stars are?
Not really.
Sorry, Jim.
Sorry.
This is one of the phenomena about stars, right? So, for example, if you're taking an angle measurement object, let's say a mountain, right? As you increased in angle, the angle to the top of that mountain is going to descend downward, change. Now, when we do the same thing, right, go to the top of it and then measure the elevation of the star, the angle changed from whence we measured it at sea level. So the stars don't act in the same way as terrestrial objects. As we increase in angle, the angle that should change, if they were to have a point in the sky of location that should change, it appears to not. So using this triangle, we can't figure out the distances to stars, and it's kind of a false premise anyway. It would mean using this method 2 times earlier, that with distance, the star measurement would be getting closer to the floor.
Yeah, you were breaking up quite a bit there. I missed.
Sorry, I do apologise.
I want to hear what you have to say. Can you say it again? Because I missed some of that.
I think he left.
Oh no! Does anyone remember what he was saying about parallax? Can they rephrase it to me? Maybe they got it better than what I was getting.
Yes, I remember. He never said anything about fucking parallax. How's that?
Well, no, he's talking about navigating using the stars, and parallax does the same thing. So
correct. We don't use parallax to navigate. It's not even in the book anywhere. So I don't know what you're talking about.
Okay, would you agree? Depending on what time of year it is.
No, I don't. I don't agree. No, I don't. No, I don't. You use an angle to a star to navigate.
He was saying that while the angle to like let's say Polaris will change with linear change in distance horizontally, right? When there's a phenomenon where you go vertically and the angle remains the same from the same location. Okay.
Are we talking about the summit of the mountain? like the tip?
The stars. So the angle to the listen, the angle to a top.
The guy's doing it on purpose anyway.
The angle to the top of the mountain. I know, but one sec. The angle to the top of the mountain, right? If you change your elevation vertically, right, you'll get a different angle to the top of the mountain from the same location as opposed to on the ground. But that doesn't happen with the stars. You get the same angle. You get the same angle.
Can I still man your positions to make sure that I'm understanding your position fully? You use illustration of a mountain summit at the very peak, and then when you move location, when you move down the mountain, that summit's going to change relative to where you are. The angle will change.
No, that's not what I'm saying.
Okay.
All right. You know what an elevation angle is, right?
Yes, I'm with you.
Okay. Right, so don't go anywhere. Stay in the same location, but go up. Right?
Okay.
So keep that ground position and just go up. Right?
Yep.
So you're going to end up being, if you go high enough, your eye level, right, is going to be level with the top of the mountain, right?
Yeah, I see what you mean. Okay.
Right.
So when you're looking down.
That angle's going to change. So your elevation angle will change when you're taking an elevation angle to the top of a mountain or a lighthouse. That'll change with elevation, but it doesn't change with elevation with stars. That angle remains the same. So you could be on the ground and take an elevation angle to Polaris, and you'll get an angle measurement, and then go to 30,000 feet, and then take the angle measurement again to Polaris. It's the same as when you were on the ground.
But doesn't that imply that the stars are further away?
I don't know what it implies.
It does imply.
I'm making a claim.
If it's further away, surely the more you change your location, the less effective it will be.
Dude, there's something wrong with you. You keep wanting to talk about distance to lights in the sky. There's something mentally wrong with you. Do you hear it yourself?
Bro, I don't know why you keep getting so angry. He's made a good point there. Like, you're looking at the evidence and you're trying to make deductions of what you see. He's asked a good question. Doesn't that imply that the star's further away? You can't just then insult him and think that you've proven him wrong. It doesn't make sense.
Yeah, no, it's a flawed methodology because the accuracy is the room for error is just too great to be using that methodology to prove a shape when you can be actually measuring the surface, as you know, Oleg. The golden standard is. Let me just finish, please. The golden standard is to measure the surface of the Earth. You can't be looking to the stars to determine the shape.
Yeah.
Thank you. Don't allow me to finish.
Sorry, Jen, but just what you just said. You said it's fucked up because that what we were just talking about. It's like you gotta wait. So I gotta remember what you said.
Do you want me to reiterate to you?
The elevation angle doesn't change to Polaris. When the previous guy said about it, like according to like our model of the cosmos, saying it's like trillions of miles away. Do you realize how the angle wouldn't change at those distances because the distance is so extreme?
We can have a distance where the angle isn't going to be perceivable when we change a small relative elevation from the surface at a distance. Okay?
Yeah.
And?
So you're not going to measure a change in angle at height because the distance.
So it's hard to figure out that exact distance using our methodology here. Because the angle doesn't change, it's imperceivable to us because it's a quote unquote, let's say, magical distance. Whatever the distance is at this distance, the angle doesn't change. So we're not going to be measuring distance to it, then, are we?
No, but then you wouldn't like. I don't get what you're trying to reason.
What, that we're not going to be measuring the distance to the star?
Yeah, but I'm saying the the angle would be consistent in the sky, globe or flat.
Yes.
Yeah.
Yeah. Well,
But
high fives all round. Should we have a beer?
It does change based on latitude.
Yeah, that's when you move horizontally away from its geographical position. Based on how you, the observer, sees the world, it's called the celestial sphere, like a dome of vision around and above the observer. That thing that was above your head as you move away from its geographical position appears to descend downwards towards the horizon. Yeah?
But you have to, for its angle to change, right, that implies that the distance from it is increasing by a measurable degree.
Sorry, a measurable degree? From where? The surface, at altitude?
So
does it get closer to the? Sorry, does it get closer to the floor the further away, or closer it gets to the horizon?
It's literally a measurable degree, Jedi. I'm sorry. It's a literal measurable degree, as the degrees are translated into the distance on the ground, or something like that. But the degrees are a distance.
If you have a measurable change, you'd have to have some sort of change in distance or curve.
Exactly. That's the thing. The change in distance is directly under Polaris and then walking away. That change in distance gives you the change in perceivable elevation of the star.
So then you could figure out using trig a distance to Polaris.
No,
you can't.
Because, sorry, Eli, because like I've said, I think it's 6 times now, the star is not actually getting closer to the floor with distance. Basic trigonometry.
So you guys not familiar with parallax at all?
No, it's not that the star is getting closer to the floor, right? It's that you are getting closer to the star. That's trigonometry.
You guys got to stop drinking or whatever is causing this brain rot you have.
Not brain rot.
This is trig.
Another ad hominem. Great, man.
This is just trig. If you're what's the one hypotenuse over adjacent? If your cosine angle is larger,
perfect. You know what? You just proved the Earth is flat because you can't do that on the surface of a ball.
You can.
Second of all, no. Listen. No, you can't. Number one, no, you can't. But what was I going to say before that?
Yeah, you can. Check chat. That's exactly how you do it with simple dash geometry.
No. We're not doing. The thing is, when it comes to celestial bodies, you don't do trigonometry. So why are you doing that?
What?
Why?
What?
What do you mean? Google it. Because you
don't do it. What do you mean? I just gave you an example in chat right now. What are you talking about? That you're just flat out lying. That's a lie.
You can't do trigonometry.
We can, and I just presented evidence in chat. So chat is just non-existent.
Wait, hold on.
So
what's
his name?
We've already said in.
We're gonna slow down right here because I'm gonna mute you both. Look not what you're using the stars though.
Well, so if you look at his diagram, how he's using trigonometry is he's waiting for the Earth to be on one side of the Sun, and when it goes all the way around to the other side, he'll take a map of the stars and see which stars have moved, and then we get your angles from that. Just to help you out.
That's been the question.
So I think if you want to argue it, I would try and attack the angles of the changing of the stars. I think that's.
Yeah, so what you're saying is he doesn't have any parallax unless he creates an imaginary baseline by assuming the Earth is on the opposite side of the Sun in free space, which is part of the thing he needs to validate in the first instance. So he has circular reasoning at best. Wow, that's worthless.
It's only circular if you don't believe that the Earth orbits the Sun. Is that your position?
Okay, so we need to believe in your position in order to understand your position. That sounds like a religion to me.
I mean, we can go point by point if you like, but if you can tell me what you believe, and then maybe
No, I don't care, dude. If you need to use the Sun being on the opposite side of the Earth and the Earth being a transposed distance as your base leg, you have to prove that three-dimensional relationship exists in reality first, dude, in order to use it. It's not my option whether I need to believe it or not. Why don't you just prove it? Go ahead.
Would you agree when you look in the stars and you look them, and then 6 months later they're in a different position? Would you agree?
Who cares? How about you just make your point? Why do I have to answer questions?
Well, because the stars have changed location after 6 months, you can either conclude either the sky has moved even further from its other reference point, or the Earth has moved.
Cool story. So how about you make a point? What are you doing these dramatic pauses for? Aren't you supposed to be proving your point?
I don't want to. I would imagine you would contend with something that I've said.
I could care less, dude. See, try making an argument where you prove all your premises and you carry the conclusion. Why don't you try doing that? How about it? Go for it.
Sure, but in order to use parallax, I need you to accept that the Earth orbits the Sun.
No, I don't need to accept it, dude. You need to prove it.
So, what do you want me to prove first, parallax or the Earth route?
No, dude. If your consequence rely on previously proved premises, dude, you have to prove those premises first. So, if you need the Earth to be on the other side of the Sun for your next argument, prove that first, then carry that proof and the conclusion as a premise in your next argument. Good grief! Don't you know how this works?
Yeah.
Elijah, man, go on mute, bro.
Oh, sorry.
Thanks. I know, bro. Cat got your tongue. You don't know how to prove your case. You just want to make everyone get on a belief ladder. Do you believe? Do you believe? Do you believe? Do you believe in the Holy Ghost now? He'll make it over the globe now. Do you believe faithful in the pews now? How about you just prove your case? How about that? Is that so hard?
I just wasn't expecting someone to say that they didn't think the...
Oh, you weren't expecting somebody to ask you to prove your case? Wow. Hard one, bro. How about you just prove your case?
I did give you evidence, and it's this changing of the stars over the 6 months.
No, dude. That's not evidence of anything. What you gave me was an assertion that that's what the stars do. Maybe a claim.
It's not.
Maybe a true observation. Hold on. Maybe it's a true observation. But you didn't put it in the form of an argument that it helps your case or proves your case or does anything to advance your case. You just left it as an open-ended, question for the faithful to stand to and say, I believe, sir. Amen, sir.
Okay, here's the argument that the Earth orbits the Sun. First one is obviously the movements of the stars, which I've always mentioned. So if the Earth is literally moving its position, then the Earth is moving, and it's not the Sun that's moving, it's the Earth moving around the Sun. And then we know this because the stars are moving, and we can map this every 6 months.
Oh, hold on, brother. Hold on, bro. That was a circular tautology loop, bro. You said either the stars are moving or the Earth is moving. And if the Earth was moving, the Earth would be moving. And we know the Earth is moving because the stars are moving. So you got nowhere, dude. You ended up back where you started, where you have a possibility of either one being the one that's moving. You didn't exclude one or the other. Dude, what do you think this is, amateur hour? What did you think you were in the vegan room? Hey, brother, did you think you were in the vegan room dealing with retards or something?
Saying that the Earth
some vegans make good points, by the way.
I know, but
when they have a steak, they can make a good point.
Right.
Well, look, I just want to point out that this guy made no logical advancement to his case at all. He said it could be this or it could be that, and it's the one because I say so. It's basically what he said. He didn't provide any evidence of why one explanation is excluded over the other whatsoever. So for the love of God, can you do that, please? I mean, how long do I have to be here, dude? I got a finite lifespan. I'd like to get to you making an argument before I die. How about that? Is that fair?
Will never happen. I have made an argument, but we'll go slowly.
No, you didn't, dude. You know you didn't. Let me explain it to you. Let me explain it to you very simple.
Go for it.
Here's what you said. Either the stars are moving or the Earth is moving. If the Earth was moving, it would be moving. And we know the Earth is moving because the stars are moving. That's what you said. That is a horrible argument, dude. That is a big pile of steaming turd.
What position do you hold?
I don't think you said that, though.
Yeah, that's what he said, dude.
Stars moving.
And that's
Doesn't
how he
matter,
wants
dude.
to justify a relationship between the Earth and the Sun. It makes no sense to make a claim about a relationship between one party and another party, and then your proof for that or your justification for that is to bring up the third party, as if that has any.
For example, Alicia, why is he asking me which one I believe? Isn't he supposed to be proving one is true? I thought that was what he's supposed to be doing. Why is he again asking me what I believe? I forgot. I thought I was in a 24/7 flat Earth, not in a church.
He doesn't know what he's doing. I think he's confused.
Not confused.
No, he's been eating too many carrots. I don't know.
I'm trying to explain it, but you just yell at me.
I don't care, dude. I don't care. I don't care. What I'd like you to do is I'd like to stop talking, and what I'd like you to do is to make your claim, and then you explain why your parsing is correct with evidence and reasoning that actually is a sequential reasoning and not just a circular loop that leads to a conclusion. For example, you might say, I know the Earth is moving relative to the stars because of this. A, B, C, and D. Kablam. There's the conclusion. Like, it doesn't require you asking me what I believe. I don't know why you don't get that. All right, go ahead. For the love of God, please.
Sure. We know the Earth is moving around the sun because we see a shift in the stars.
That's retarded. How can you know that How can you know that the apple came from the tree because of the graph?
Let him finish. Let him finish.
It's retarded. A is this with respect to B because of C. It's stupid.
I know that. I know that's fair.
You haven't established any relationships. You haven't established any core proof, core principle.
All right, Alicia, stop talking or get kicked. Thanks.
Was I over talking?
Okay, we yielded the floor to that guy. Okay, we run this room. So if we yield the floor to somebody to complete a point, and you guys want to butt in on his point, you better be a mod. Otherwise, you're getting yeeted. Does that make sense?
Yes.
All right, I want him to just make his point. Now, before he goes on, I just want to point out to the previous person who told me that he didn't say we know the Earth is moving because the stars are moving. He just said that again, dude. Doubled down, tripled down. For the love of God. I'm right, as usual. All right, now, I'm going to mute this kid. Please don't interrupt him so we can just get through it, as painful as it is.
Well, hello there. So my argument for the sun revolving around the Earth, I won't mention the stars again, that triggers the fuck out of people. So we'll go for planetary motion. So a retrograde motion of the planets like Mars, where they occasionally appear to move backwards against the stars. This is observation that we can do, so I'm only sticking to that. So it makes perfect sense that the Earth would be overtaking them in the orbit, because obviously Mars is on the outer orbit and we're on the inner orbit. So we would be our orbits would be faster than Mars going around the Sun. We can also look at Venus, because Venus is in a tighter orbit. Through telescopes, we can see that Venus goes through a full cycle of phases, like the Moon. Which can only work if Venus is orbiting the Sun much more closer than the Earth does. And then the other argument would be gravity in physics. I'm not sure what you guys feel about gravity, but Newton's law of motion says that gravity must naturally explain why planets orbit the massive Sun rather than everything orbiting the Earth.
All right, perfect. So let's break it down. So You said when I look out at the stars, and you then included celestial bodies such as the so-called planets, you said that we see them moving across our field of view from our vantage point. So either they're moving or the Earth is moving. And we know the Earth is moving, let me put it to you simply, because they are moving. So again, that was your argument. The Earth is moving because they're moving. That's what it boils down to, bro. You didn't actually explain why it's necessary that the Earth is moving. You just appealed to a kinematic model, placed the Earth within a kinematic model, and then said, based on my kinematic model of something else moving, I'm going to infer the Earth is moving. You didn't actually prove the Earth was moving, dude.
So when you look up in the stars, you can see Mars. You can see
Mars, I can see the stars. Yep. I can see the stars and Mars move. You're right. So I see other things that aren't the Earth moving. How does that prove the Earth is moving? Go ahead.
Sure. So the model is that we're orbiting the Earth, so that we should see Mars have a really weird. Mars will look very weird in the sky. You'll look at, it'll jump ahead and it'll circle back on itself. The only way you can explain that is if Mars is orbiting a celestial body.
Yeah, cool story. Cool story. That you're wrong. You're actually wrong, dude.
Okay, go for it.
Because you made an exclusive claim, right? That the only way to explain that, okay? So what you're actually doing is showing incredulity, because you're saying the only explanation that I think is true. I could just make an explanation that it's a fantastic differential medium that's actually controlled by cosmic entities to create an apparatus of angles of light that we receive on Earth. Now, that's an explanation. Now, you would say, no, that explanation doesn't make sense. So it's not true that it can't be explained other ways. It just wouldn't be satisfactory to you. So what you did, like I said, is create a model, place the Earth within the model, use the kinematic equivalence of the motions of things, plot them into your model, and then say that model is true. Now, if you say my model is true, and it's true because it's a model that has an explanation, that would actually be called a reification fallacy.
So you are correct that I'm using a model, but what we look for in a model is like, does it produce repeatable results, and can those repeatable results be measured? And I would argue that this model
that doesn't mean that the model that doesn't mean the model's correct, dude. So, for example, epicycles is a very accurate model. Is epicycles true?
This is the first time I've heard of Apple cycles, or whatever you call that.
Yeah, they're a kinematic equivalent. They're a kinematic equivalent of the cycles of the celestials based on observation off of a flat plane, and they do a quite accurate prediction, dude. You didn't know they're a kinematic equivalent. They're a kinematic. What? That doesn't mean that the model that doesn't mean the model's correct, dude. So, for example, epicycles is a very accurate model. Is epicycles true?
This is the first time I've heard of Apple cycles, or whatever you call that.
Yeah, they're a kinematic equivalent. They're a kinematic equivalent of the cycles of the celestials based on observation off of a flat plane, and they do a quite accurate prediction, dude. You didn't know there's multiple models of the cosmos. You didn't know that they all work. You didn't know that there was a book. You didn't know there was a book called The Great Controversy on the Two Great World Systems, where the dudes had a debate about this very type of thing. And the narrator of the book, who did the foreword, basically said that both guys have an equivalent kinematic model. If they both have an equal model that gives the predictions accurately, and they're arguing which one is true, how could they both be true? But they both have models. That's weird. I thought you said if you had a model, that means it's true. But how could you have two models? If you had two models, how could one be true and the other be false? How could they both be true? It makes no sense now.
Not necessarily. I'm not familiar with what you're referencing, but yes, you can have two competing models, and then it would be on your behalf and on my behalf to defend each model. So I'm open ears for a flat Earth model. Like, how would you explain why the stars change?
That's not the point. You missed his point.
I'll repeat back what I think he said, and maybe you can correct me. He said there's a book where it contains two models, and those two models made accurate predictions and the conclusion of the book was that both have equal standing. Basically, both equally could be true, but we're not sure which one it is.
Yeah, the commenter on the book. By the way, these are the bigwigs back in the day of the early formation of the heliocentric model we came to know and love and be oppressed by in schools, being forced down our throats without question as a religion. But anyway, the guy who critiqued the book said, this guy and this guy, they equally put forth a valid kinematic model based on the observations. But that doesn't mean that, he even said in the book, that doesn't mean that their claims about the actual physical locations are true. See the problem there? So these guys who were involved in the inception of all this, they knew that they were just making models. Fast forward to today, and guys like you don't understand the difference between models and reality.
The idea, well, it goes either one or two ways.
Yeah, I'll give you a model right now, brother. Critique my model real quick. The cosmos are the cosmos, and uniformitarianism isn't necessarily true. That means that the Earth can operate one way and the cosmos can operate one way. And the assumptions of physics and interactions between three-dimensional free space on Earth isn't necessarily projected into the cosmos. Therefore, the Earth can be flat and the cosmos do something that, falsely interpreted, would give you the impression the Earth could be a globe based on a model, but the actual surface of the Earth measures flat because your assumptions about what the lights are doing and where they are is false. There, how would you like that?
Sure. Can you define for me what the cosmos is?
Yeah, everything that's not the Earth, dude.
So would you include the vacuous space? Right.
So, in case you didn't know this, friend, and I'll just drop this knowledge on you. Throughout the majority of human history, the idea of uniformitarianism, which is that everything is the same everywhere in the universe, right? It all operates on the same principles, that wasn't believed. Most people believed that the Earth was a terrestrial realm, and it had a certain level of operations, and that the cosmological realm, the greater than the Earth, had much different types of interactions, or forces, or powers, or even elements. It wasn't until modern day that they tried to synergize everything into one, grand explanation.
Right. So your premise that there are like multiple models, and you're objecting to this unifying model. If I did a very short summary of what you're saying,
I'm objecting to the fact that you haven't validated any of your claims about the locations of these things in free space any more than the guys that were in that book, or the guys like Ptolemy and Copernicus and Galileo and all those guys did. Like, you haven't advanced any evidence or any proof that what your claims are true. You're just presenting model upon model upon model, and then you make predictions within the model that are kinematically equivalent. That just means where the thing appears to be in its motions. It's not dynamic, which has nothing to do with the forces of why things are doing what they're doing.
Yeah, because there's two ways we create models. One, we perceive what we can gather and then make models around our perceptions, or we make models and then do the perceptions and seeing which was correct. I believe when it comes to when you're looking for evidence, I've always started my arguments by looking at something. So I reject the idea that no evidence presented. I am actually presenting something that you yourself can observe, provided that you're not in light pollution area.
No, you're wrong. You're wrong, sir. You're wrong. See, here's the problem. You think I can observe what you're saying. But what you're saying is that the Earth is orbiting around this or that. But no one's actually observing that. The only place you're observing that is if you draw it on paper or put it into a computer program and make a graphic that's moving. No one observes what you're saying. What we do observe is the celestials moving around the sky. That's the only thing we observe. Everything else is some kind of model that you're creating in your mind. It's not an observation.
Do you think we can extract reality from models?
No. That's called a reification, dude.
I would agree with that.
Isn't a flat Earth a model?
I made a model of a magic wand, and it doesn't produce unicorns for me. What happened?
I think we're talking past each other. I think we're talking past each other. When I say model, I'm not talking about like a physical model that you have in your room. I'm talking about basically a set of principles or maths or observations, and that create predictability.
Yeah. I'll take you that, brother. Predictability based on a model, perfect. So I'll explain it to you. The flat Earth model. I'll lay it down for you like a ton of bricks. Here we go. Flat. The only way to model flat, okay, in any sense, is all extents of the variations of the height and depth is much less than the extents of the width. All points on the surface between two parallel planes. That is the model of flat. Now, when you go out into the Earth, if that were true and it was predictable, then you would find out that all points on the surface are between two horizontal parallel planes. Now, we know that the standard of level is sea level, and all heights on the surface and depths on the surface are measured from sea level, right? And we know that sea level is in reference to the seas, the waters that cover the vast majority of the Earth, greater than 70%, some say, 60% being contiguous bodies of water. Now, since water is the gold standard of level, and we know that water at rest is flat and level on the surface, you then have a claim based on a different model that flat water is actually curved. Therefore, curved, wrapping around itself, wouldn't fit the previous model of the definition of flat that's practical and mechanically able to be executed in reality. So all you have to do, my friend, is just measure the water, and if the water isn't curved, then that means that level that extends across 70% of the territory isn't curved. And if all the points on the surface aren't curved, but are actually parallel to sea level, between two parallel horizontal planes, then the Earth is flat. So yes, it's very consistent with that model, because there is no curvature on the surface of the water.
Sure. I'm going to say something, and then I'm going to tag. People are asking me to be tagged out, so I'll let you have the last word on this. But the water
he left. Don't worry about it. He left already. He got out of here.
I have a question though. Whenever you're done.
Sure. I don't want to take up all the floor, but to answer your question, I would say that the sea is actually curved, but at a local level, it would seem flat.
Doesn't matter.
And the reason why we would know this is because you can't see past the horizon, not without.
Okay, yep. So that's another model, dude. That's another model in your mind. You created a model of your mind of what's going on at the horizon. You didn't witness that. You created that in your imagination.
How am I imagining not seeing past? I mean, I do wear glasses.
No. Listen, dude. I'm an artist by credentials, okay, and a teacher in that regard. And we teach the kids a lesson, because sometimes you will imagine the way the world is and you'll try to draw it, but you'll be frustrated because you can't actually draw three-dimensional relationships on a 2D surface. You have to use techniques that result in the alteration of the lines to be either shorter, at a much steeper angle, etc., like foreshortening and perspective effect. So we tell the kids this mantra: draw what you see, not what you know. So if you see out into the horizon, you see, oh, there's a horizon line. I have, the color field of the water, and then above that's the color field of the sky, and I really can't see anymore. That's an accurate description of what you're seeing. Now, some people will look out and say, oh, I'm seeing the curve of the Earth curving away from me around a giant ball floating in space. Well, guess what, friend? You didn't see that with your eyes. You imputed that onto the observation with your mind.
Not a hill of water.
I see what you're saying. So I think the next question would be how would you determine how far can you see in your model? And I would argue in my model, there would be a limit to how far you can see, because eventually it would curve off.
Okay, so you made that sound like if the Earth was flat, there wouldn't be a limit. That's weird.
I mean, you can see the stars, and then they're pretty far away.
Okay, so let me ask you this question. Can you see through something that is opaque? And the definition of opaque is cannot be seen through. So can you see through something that can't be seen through? Yes or no? The answer is yes, obviously. I'm sorry,
Yes.
the answer is no.
No.
You can't see it. Yeah, sorry. We agree that you can't see through something that can't be seen through. Now, interestingly enough, friend, we get it all the time. If the earth was flat, why can't I see the Eiffel Tower from New York City? Right? Here's a simple thing. Simply enough, the atmosphere at ground level has an occlusion rate defined by Raleigh's atmospheric occlusion extinction coefficient, which means that approximately, as with general specifics, the maximum you're going to be able to see before the atmosphere becomes opaque is approximately 300 miles on the deep end. So that means that looking out across the oceans, you'd never see past 300 miles. Now you might say, "Oh, but I can see a star." I'm glad you asked. Notice how I said looking out across the ocean. Once you start looking diagonal, the coefficient wanes because the atmosphere wanes. So the amount of ambient occlusion between you and the target is reduced. So the idea that you could see stars up in the sky is highly irrelevant to what you could see looking across the ground. So we already have one factor that would limit your ability to see indefinitely. Secondly, all optics have an angular field of view, right? That means light's coming in at angles. Now, the fact that light comes in at angles means it has to cross the focal plane, and then those angles are flipped. And then they get bigger, and then they're cast on the sensor, which is where the image is resolved. Now, the problem is that light, once it reaches critical angles, actually interferes with itself, and it interferes with the same receptor, which means you don't have an infinite resolving ability. You cannot see everything in your field of view. You have a limit, and it's called an angular resolution limit. Now, interestingly enough, as light approaches a critical angle, for example, the human eye, the critical angle is 0.02 degrees. That means that in an ideal situation, you couldn't resolve anything smaller than 0.02 degrees. If the light is entering straight into your eye, below that resolving limit, you're not going to resolve any of that light. Can't be done. Now, you might be able to resolve less because your eyesight sucks, but you're not going to resolve more because that is based on physical limitations of the aperture. That means the size of the hole that the light's coming in and the physics of light itself, because light actually has wavelengths and stuff and it can interfere with itself. So as you look out into the distance, this angle starts to compress. And you think, because you learned linear perspective, that this is going to be a linear rate all the way out as it keeps going, but that's false. The actual physics of light cause it to be a hyperbolic rate. So it appears linear as it approaches the critical angle, and then it takes off dramatically, very quickly, and you lose resolution. So if that angle is happening out horizontal, for example, interestingly enough, if you map out the human rate on a horizontal line extended out from your feet, the angle would reach the ground at approximately 3.5 miles. So at 3.5 miles out, you're going to start losing the bottoms of objects. Nothing will be resolvable. The stuff above the horizon and below the horizon will merge and become lost. So I have a very adequate physical explanation on at least two fronts of why, regardless of the shape of the Earth, you wouldn't be able to see forever. So the idea that if the Earth was flat, you could just keep seeing and seeing and seeing and seeing is just erroneous on its face.
Yeah, I understand what you're saying, but what would you say is the maximum distance for the angular resolution? Like, how far could you say, according to your model?
Depends on the angular size of the object.
Sure.
Other than that, I thought I said 0.1 degrees, right?
Well, the distance I described was the atmosphere causing the light to become extinct. So that's one distance. The angular size distance relationship depends on the angle to the object and the size of the object. So it's not a strict distance demarcator.
Not going to lose sight of a bee as it flies away from you well before you lose sight of a great big fucking aircraft carrier.
However, if the bee is basically 6 feet above the ground or lower, or the aircraft's bottom is 6 feet above the ground or lower at a specific distance, the portion that the bee is occupying and the portion that the bottom of the ship is occupying will both be unresolved, and you won't see either. Now, I got an awesome video for you, bro, if you're actually interested in this. And it shows you the angles. Now, this is 8 minutes long. 6 minutes of talking about it and 2 minutes of demonstration. But the 6 minutes shows you. The 6 minutes shows you just very distinctly and quickly, like I think 4 different points. So point 1 is like angular resolution in the eye. Point 2 is why are things cut off from the bottom, and the other 2 I can't remember, but they're done in a graphics program. They show some graphics that are like infographics, and then it shows you the angles from the observer to the object, and it shows you the portions of the objects occupying these angles. It's very descriptive, very simple. It's not even narrated. It's just straight text. It's super, super quick, easy, and simple to get this point across.
Sure, I would definitely give that a watch if you can link it in the side chat.
Nigger.
Yeah, cool story, bro.
Yes, I'm here.
Just to contend with what you're saying, I would agree there is such a thing as angular resolution. I also agree that light does dissipate. God damn it, that word, dissipate the further away it is. However, I just don't feel that it dissipates enough. Like you would be able to see large buildings.
Cool. What a feeling. Yeah, that's cool. Yeah, but
they'd be just very blurry. That's
I know, bro. I know you think that, and that's why I'd love you to watch this little video. But keep in mind, bro, you switch from facts to feelings real quick. So can we just take feelings and put them in the garbage can for a minute?
Very interesting choice of words you're using.
You didn't come through there, Palma.
Disagree. This is disagree matter. He's telling you exactly how your eyes and optics work. There isn't a disagree or agree.
All right, I'm going to post this video right here, right now. So who was the guy who was supposed to tag with it?
That is Joshua.
All right, super cool. All right, so let me go. Let me do. Let me get there. There we go. So at Joshua.
Yo, AI is freaking cooking right now. Good job, AI.
I'll come back with this. Give me a couple of minutes. Feel free to tag someone else in.
Well, dude, there's no reason to attack anyone if unless they're being a dick. But if they're just presenting a worldview, which, by the way, is a worldview they were taught, they really never parsed it out or made it their own. Like, why would that be attacking an individual? We're just saying this worldview that you were forced to learn as you grew up and were indoctrinated with in all media and government and whatever. Like, maybe that's wrong, bro. How is that an attack on that person? Unless the synergy of the worldview and the person are identical to where they've merged it with their ego. So to attack their worldview is to attack the person. So now they're afraid of being killed because if they lose their worldview, they lose themselves because they are their worldview. That's weird. Maybe you should have that looked at. I suggest a good therapist.
The reason you're taught it and it's forced down your throat at an age where you have zero critical thinking skills.
No, it's worse than that, brother. It's that as you're a child...
Where you don't even have the idea or concepts of critical thinking.
Yep, cool, yep. We got that, dude. So now you just repeated yourself. So I'm telling you, it's worse than that. So let me explain. When you're a child, you have psychological developmental stages to where your mind and your body are coming online to new rank ups, essentially. So, for example, one of the first ones is walking. Then after that, it's language. So you don't actually have to teach your kids language. You just have to teach them the conventions and the token association pairs. They already are coming online with the process of language. And by the same token, there's another one that has to do with who your identity is. And that part of that is who your family is, who your loved ones are, who your enemies are, what to be safe with, what to be afraid of, and where you are. And so when they give the kid the globe idea, they're giving it to them at a time when they're psychologically predisposed to craft where I am, who I am, my tribal identity, my location identity onto their psyche. So yeah, it's much worse than just they don't have critical thinking skills, is that they're literally in the mood internally to adopt that identity onto themselves. Normally that comes from your tribal parentage, right? But the government has decided, no, we're going to take over. We're going to tell your kids who they are. We're going to tell your kids where they are. And then they're going to be stuck for life with this imprinted on their psyche. Now, by the way, friend, this is well known in psychological circles, that children operate and believe and talk as if the world is a flat, motionless plane. And that it is not until they're told the earth is a globe that they even think about it. And they then have a conflict with how they directly experience the world and what they're told the world is. And so how kids deal with this is they compartmentalize the cognitive dissonance by saying, okay, while I'm living in the world, it's flat and stationary. But when I go out of the world and look back at the world, it's a globe. This is well known in psychological circles, written about all this. And then finally the kid resolves it and says, okay, everybody's telling me it's a globe. You know, the government, the media, the graphics on TV shows and cartoons, so I'm just now going to accept I live on a globe. And then they kind of resolve that, and then they don't have cognitive dissonance about it anymore. Well known.
Would you want schools to teach that the earth is flat and motionless?
Oh, they already do. But then they deny it. So here's how they do it. They say, you experience the earth as flat and motionless. That is exactly what you experience every day. However, that's not true. That's a lie. Your experience is a delusion. The actual truth is that you're hurtling through space with 11 different vectors, some of which are millions of miles an hour. And not only that, but the earth is a globe. And even though you experience it as plumb and level everywhere you go, there are people in Australia upside down compared to you. So they basically teach the kids to deny their own experience and to accept a delusion, which is something that they can't validate.
Would you not think a significant portion of the population, just like we see in science with contentious theories, and you're saying this is not only contentious, it's like plain ridiculous, would you not expect to see a massive split?
We do not care.
Oh, you mean like millions upon millions upon millions upon tens of millions of people who don't think the earth is a globe? You mean like that?
Where are all these? There are billions of people on the planet.
So what?
Where are all these people?
Yeah, for example, Brazil did a census of their populace, and they found at least 11 million people that identified as flat earthers. They did a poll. Hold on, they did a poll in the Western world, the United States specifically, and a couple European countries, where 40% of the ages of I think 18 to 32 said they didn't believe in the standard model of the cosmology or that Earth was necessarily a globe. So yeah, not only that, but we have over the past 10 years the relevant search results for flat Earth overtaking the most popular search results, like Justin Bieber, even overtaking Donald Trump. And then shortly thereafter, the United States Congress got involved, had a hearing, and decided to censor flat Earth.
Do you think, because obviously if I type in stuff, that's not saying I'm a flat earther. It's saying that I'm interested in this idea of the flat earth. But do you get the difference there?
Yeah, dude. I'm talking about content creation, because we watched it happen, dude. In fact, Mark Sargent chronicled it every week on his radio show. He kept up with it. So we know that it was resurgent of people who were actually producing flat earth content and claiming to be flat earthers, not just simply people who are interested in it. And keep in mind that the rise of people being interested in it was only the case because of the rise of people believing it or accepting it as true or questioning the globe. It wasn't just like all of a sudden the majority of globe earthers in the millions that were interacting with the search results just decided of their own free will for no other reason to just be like, oh, I'm just going to search flat earth for some reason.
So wait. So you can't identify the exact motivations for people searching something, or you just call me a flat earther because I search stuff that's associated with it.
Wow, dude, that went over your head, didn't it?
So what did I miss?
I'm back.
What you missed is that about 10 years ago, actually 15 years ago, and slightly 17 and a half years ago, there were a few key points that came out. One was the advocate of the Principle movie, which was done by Robert Sungenis, which was a geocentric conception of the universe, and he attacked many of the old heliocentric assumptions in this documentary. Sideways to that, there were a couple of flat earthers who were on the rise, one being Matthew Boyland under the moniker Matt Powerland. And he was a NASA employee who was approached by another NASA employee at a party, and he was told the Earth was flat. He then, based on his job, realized something because he was an artist. That his job was designed to paint all of these worlds as spheres and all of this space and all of this stuff. And he realized that he was basically living a lie, that he was projecting out all of this imagination about space and the Earth as a globe. But really, all he ever experienced of the Earth being a globe was a painting, because that was his job for NASA. So he went on a comedy tour to actually ask people on a T-shirt, is this a painting or is this the Earth? Is this a photo or is this a painting? He went on a tour. He would go on the street. Ancillary to that, we had a few flat earthers come on the rise. Like within a decade was Mark Sargent, and before him was a guy by the name of holy crap, his name's escaped me. Eric Dubay. Now, Eric Dubay's rise to fame was that he was tapping into literature that existed for the past 100 years. For example, books that were written about the contention between heliocentrism and the flat Earth. In case you didn't know this, flat earthers used to go on collegiate tours. They would go to universities and colleges and debate flat Earth, and they wrote books about it.
I know.
So all this came to a head. All this came to a head in the social media and that type of venue on the internet about 15 rolling into 10 years ago. And then in the 10 year, it really took off. And that is when the people making flat Earth content and saying they were flat earthers started getting into the millions. Okay? And when I say relevant search results, the relevant search results are not people searching for the term, dude. They're what they find when they search for the term. That content was created by flat earthers. And it started off in the millions, then went into the tens of millions, and then surpassed Justin Bieber and Donald Trump. And very shortly after that happened, YouTube decided to change their algorithm and coordinate with the Congress of the United States to shadow ban and intentionally thwart the efforts of flat earthers who were just talking to each other to skew the results and to make it to where you could no longer find that good content. So yeah, we all witnessed this happen, dude.
Why would they not just censor you? You're on YouTube Live now. Why would they not just censor you?
Dude, why do you think?
That's why I'm asking.
Oh, because in the United States, we got liberties and freedoms that are constitutionally protected, and the Congress just can't stamp you out. They have to do it with shadow techniques, for goodness sake.
No, that wouldn't apply to YouTube.
Yeah. Yeah, it
no,
does.
it doesn't.
Attach that box to the YouTube stream.
Yeah.
YouTube is a private. YouTube is a private.
The archaic notion.
Hold on. This moron skipped the part where the executives of these companies met with the United States Congress to come up with a plan to censor flat Earth, dude. Good grief.
They're doing a bad job. I can search David Weiss, Eric Dubay.
You have to search for specific people. If you just search flat Earth, you're not going to get like prime flat Earth positive content.
Yeah. Look at. So you search David Weiss. Hold on, friends. You search David Weiss. David Weiss is on record in an interview being asked explicitly, "Is the Earth flat?" and he doesn't answer. Okay, guys like David Weiss and guys like Eric Dubay are a little more on the esoteric mumbo jumbo side. So when you're doing a rollout like this, imagine, if you will, a great example of this is the Matrix movies. So in the Matrix movies, you have the Resistance. They're searching for the one. They find Neo. They tell Neo, "You're the one." Then they go on this mission, and then they end up finding the architect. And when Neo meets the architect tells him, "Bro, I invented you. I created you. You're controlled opposition. I created you so that the truth of the fact that you're all prisoners and the truth of the possibility of freedom could be played out, so that after it's played out, I destroy it, and then we repeat the cycle. And this makes 90% of the population accept the system. So yes, all of this is done to allow things to play out to where the majority of people still accept the status quo. They don't want to stamp out flat Earth completely. They want to let it play under a little bit of a control.
Your controlled opposition.
It would be far too telling. It would be far too telling if the gig would be up if they just completely banned all flat Earth churches.
Well, your controlled opposition.
Wow, you missed that part. You missed it, didn't you?
We're the suppressed part, which doesn't come up in your search results. However, the more esoteric people, the individuals who have beliefs that can be attacked, those get pushed as controlled opposition so that the globe has something to be opposed to.
Right. Do you want to know
90%, about 90%, hold on real quick, about 90% of Flat Earth content, keep in mind it's on all kinds of social media. It's being talked about in all kinds of venues. Most of it is garbage, nonsense. Hold on. Most of it is garbage, nonsense, esoteric, mumbo jumbo, religious predispositions. You know, that the stars are made out of angels' farts. You know, all these kinds of crazy claims that make it to where the average person thinks that the flat earthers are whack jobs. Where the 10% of the content is, hey, bro, the Earth actually measures flat. When you go out and look at the water, you can test whether it's flat. You can apply the physics of water and know that it's flat. They're apples and oranges, brother.
I can actually agree with you part ways. I could see them not like banning flat Earth, partly because I guess it would look bad from a free speech point, but also like even though it doesn't apply to private companies, I could see it as like a form of controlled opposition.
The world is a globe.
Hold on. I'm just saying, because I think when the government commits like actual conspiracies, they can point to flat Earth and be like, ha, you believe a stupid thing like that. I think you are like the village idiots of like, you know, the government distracting from like actual conspiracies it commits.
Yeah, you're right. No. See, if you missed the problem, you missed the point there, dude. Saying you are the village idiots applying it to us was wrong. But if you say that the flat Earth community that's being played like a fiddle, that portion is the village idiots, I'd agree.
Well, yeah, but I don't. If you think you're going about it in a more rigorous way, then fine. But you know, even in the 19th century, with that guy's book, like 200 proofs that the Earth is flat.
In the 19th century,
it was still disregarded by like most people because they just.
Hey, who cares, dude? Who cares? I could care less if the truth. I could care less if the truth is disregarded by the majority of the retards of the world. I could care less about that, bro.
well, that's the thing. AI. He doesn't seem like he's concerned with the truth. He's just doing that about flat earthers and how they get searched up on YouTube, right, bro?
Yeah, is that how you get to the truth is by disregarding information?
The scientific community retards, are they massive retards?
Yeah, a lot of them are, dude. So, for example, in case you didn't know, many of the pillars of the modern cosmogony and cosmological paradigms themselves, like Hubble and other such, echelons of greatness, they're on record admitting that they had philosophical predispositions that overrode the science, that they had choices that they had to make. And the evidence was going this way, but they went the other way because they hated where the evidence was actually going. In fact, in their own words, Hubble himself said, the idea that the Earth is the center of the universe is horrifying. Interesting. The idea that the Earth is in a physical location has a horror connotation to this man. Why? That's weird. I find that odd. And a scientist would be horrified.
Who cares about what poetic language some scientists use at some point? Who
so
the
that's the
fuck
problem with you,
cares?
dude. No, see, Cosmos, here's the problem with
Yeah,
you.
because I don't make arguments based on poetry.
No, you're not getting it, dude. You're talking about scientists as if they're this echelon of purity and that everything they do is noble and that their consensus should be trusted. I'm telling you that they are dripping with philosophical and predispositional religious biases that they force on in their interpretations of the data, just like any other person. They're not some paragons of virtue. Okay.
So they're stupid.
Some of them are, yeah.
Well, they're believers,
For example,
at least, like you are.
Yeah. Let me tell you one such stupid guy. He was asked by Ben Stein, so you admit that life on Earth could be designed. And he said, oh, yeah. Life on Earth, based on everything we've discussed, could be designed. But it only could be designed on Earth if it was designed by an alien species that evolved on some other distant world. Yeah, that guy's a retard. Let's see another guy. So another guy, he said, if you take all the positive numbers and all the negative numbers, and you add them together, that equals nothing. 0. So because of a force called gravity, surely something can come from nothing. Yeah, that guy's a retard too.
He accused you of a misquote, AI. I don't know if you heard him.
I'm struggling to find the Hubble quote in myself.
What do you distinguish as like a retarded person versus like a very clever person? What traits do you distinguish in that?
The clever people aren't infallible, you know? Like Dre said, they're human. They're not like some godlike entity that have all omnipotent knowledge or whatever, you know?
I'm asking
You're
you, how
displaying
do
a
you distinguish
little bit of phantom
between
metric syndrome.
I'm asking you, how do you distinguish between like a retarded person and a very clever person who seems to like?
Well, when you have people like you that claim that you don't feel movement, but you're moving in all these vectors.
Yeah, I saw that coming. I saw that coming. Yeah, you can give up. Yeah.
Like you.
Yeah.
No one's giving up, but you're not really trying to dig down towards the truth of what the Earth.
Yeah, you gotta be real like this, bros. It don't matter. See, when we scrutinize scientists as a person, it's actually irrelevant to scrutinizing the body of their work, because if the body of their work was done correctly, it can be presented, and it actually did follow the correct methods and leads to a conclusion, that stands alone from the fact that he cheated on his wife, or beat his kid with a stick that had nails put through it. I mean, it doesn't matter how much of a dirtbag he was. If his science was correct, then that's a different story.
Your microphone's broken, Cosmos.
By the way,
he's just typing in ChatGPT or something.
By the way, can the person who called me a retard, if I give you a maths question that isn't even that hard, and you,
oh my goodness, dude, who cares?
You
I don't think anyone actually called you a retard.
Can you?
And like, what is you're doing this whole thing where like you're not really trying to get after the truth. You're talking about people
right?
now.
So you called him.
Yeah, fair enough.
So
fair enough, but
go ahead.
Arithmetic ability can be done by a calculator. Okay, so who gives a crap?
No, it's your ability to work through an argument and compute a conclusion. Like it tells me
your ability to do arithmetic. Your ability to do arithmetic doesn't mean you're not a stone cold retard, bro. Okay, they're two different things.
It doesn't change the nature of the Earth either, which is what we're trying to get at.
So for example, brother, Cosmos. For example, you might be really good at math, but then your bro asks you, "Hey, why do you still hang out with Sheila?" And you're like, "Well, one day she's gonna leave Tyrone and be with me because I treated her so nice for all these years."
Right.
So I understand the point you're trying to make.
That's CB.
Somebody can be intelligent in different departments. You can have social intelligence, but not much, say, academic intelligence. But I feel like if you're going to go as strong as calling someone a retard, like you should probably put your foot. What's the word? Put your hat in the ring and actually have like a test with them.
But it wouldn't be through arithmetic necessarily. And if you're so smart, who called you a retard exactly?
Hey, do I need to get in the ring with somebody who thinks that numbers can cause something to come from nothing? Do I need to get in the ring with somebody like that? No, to get in the ring with somebody like that would be to dignify their retardation, dude.
Yeah.
Now, does that man have a degree, and was he a professor for a while? Sure, but he's still retarded. It's self-evident.
No,
If you think numbers could cause material realities, you're retarded.
Math is the language of the universe.
I think the person becomes a retard when that he thinks that straight lines can bend.
It's not about what you can remember. It's about how you reason. It's about how you reason what you think about.
Hang on. Did someone just say someone's a retard if they believe that land can bend?
No, straight lines can bend.
Straight lines.
So if you were smart, you would hear properly.
I mean, so you think the surface is a straight line? What do you do with mountains then? That goes against the straight line.
He didn't say the surface was a straight line. Are you retarded? Okay, it's actually starting to seem like he's retarded. What the fuck? Wow.
Obviously.
Wow. You just revealed. You revealed your low IQ.
Well, Creation Bear, keep in mind that they're just distracting from the point and talking about whether scientists are respectable or retarded or not. Because I laid it down earlier. I laid it down earlier that you could just measure the water and find out whether it's flat or not. And that was talking about something.
Speaking of points, you sent me off with a video, which is another like Dr. John D video, which I was sent another video, I think yesterday. I think it's called Peer 2, and this guy's a little bit. I think he did a good job at like trying to making sure like the temperature's right, but I think he misses like quite a few critical points. Like he doesn't measure the temperature of the water. He says there's no light refractions, and yet when you go to like minute 23, 20 seconds, there's literally a mirage of the red light. So that's quite literally a refraction. Also,
they're all refraction. They don't try repeatability. They don't try in different conditions. They never try to validate stuff they do in various experiments.
But literally,
all of these people.
Yeah,
Dr. John D got Dr. John D got numerous videos on his channel, dude.
Okay,
yeah. So does the MLSB 69. What do you mean? They don't just do.
He has one. Yeah, John D.
Videos.
Real quick, dude. John D has one where he uses two different colored lasers because then he can chart the refraction, right?
Hang on, that's the one. That's the one I've been watching. I shit you not. Watch it again. He says there's no light refraction, and then I'm looking at it right now. At 23 minutes, there's light refraction from his red light. You literally just see it. It's blurry as shit.
Okay, so post it, clip it, and post it, dude. Like, why do we got to do the work? You're bringing it up, dude. You know how hard it is to just type out, colon 23, semicolon 50, enter.
Or take a screenshot too. Take a screenshot.
Fine.
He said a refraction too. What is a refraction? Whatever.
So if you know what refractions are, they look like a mirage. Think of it like in the desert. There's like everything looks like wavy and blurry. That's light refraction.
Not necessarily.
You watch that video, please. Just watch that video and tell me that's not a light refraction. Tell me to my face.
Wait. What does not necessarily mean? What do you mean?
Well, dude, refraction is a specific case condition of light redirection, much like reflection, right? So all light redirection is not either refraction or reflection, right? There's other things. So, for example, there's Fresnel drag. So in a moving medium, right, light is redirected in the direction of the motion of the medium, right? Is that refraction? No. Is that reflection? No.
Where'd you get that sort of drag?
So if it quacks like a duck,
You could get it. You could get it from a rising heat. So, for example, one such thing with the
that is
hold
refraction.
on, bro. Holy fuck, dude! No, it
So
isn't.
glad you mentioned
It's not
that.
refraction.
Weirdly enough, earlier in his video, he talks all about temperature, but not enough to cause a fucking heat wave refractions. So I don't know. Try again.
Right. So you still haven't posted your thing, dude, about your claim about this video, dude. So how about do that first before you move on to the next claim?
Sorry. Am I going mad? Can anyone see the video that I posted? Or
Post a screenshot. Post a screenshot.
Well, you won't see the mirage if you won't see the refraction if it's screenshotted. You'll just see a blurry image.
Wait, can you AI overlord? Can you say the term? Because I can almost guarantee it's a form of refraction.
Fresnel drag.
Sorry.
Jeez, he's so high IQ. He said it. We said it twice now.
You said it really quickly. What was the word?
I caught it. Fresno.
Fresno drag.
Yeah. You want to spell it for? Do we need to spell it out? I don't hear any interest in diving down, drilling into the shit.
You're gonna have to spell it.
Oh, you do have to spell it? Okay.
Oh, let me read it. Let me read it for you. You are correct. I like that. Fresnel drag and refraction, although related, are distinct phenomena. Oh, there you go.
Right, so link me the source.
No, dude, you're on a rebut. You didn't ask me to prove it. You wanted to rebut, so you go ahead and you find the rebuttal.
Just reading
you're looking
something
for it right now. Yeah, you wanted to rebut, dude. So go ahead and find the rebuttal.
So I'm asking for your source.
No, I'm waiting for your rebuttal first.
The fact you're refusing to hide the source with me shows there's something in there which you don't want me to see.
Oh,
no.
Really?
Holy crap, dude.
So show me the source.
Dude, all I put in is Fresnel drag is not refraction. Into a search bar. That's what came up. You are correct. Fresnel drag is a related phenomenon to refraction, but they're not the same thing. Refraction is the redirection of light as it passes from one medium to another due to the change in the speed of light because of the change at the boundary in the optical densities, in which the angle of incidence equals the angle of refraction in the direction of the less dense or more dense medium. Fresnel drag, on the other hand, describes how a moving medium affects the speed of the direction of light, essentially dragging the light along with it. This effect was first theorized by Fresnel to explain the null result of the Arago experiment, which attempted to detect the Earth's motion relative to the ether using refraction. Good grief.
So